After configuring a new project in Gradle, typically the next step I perform is problem domain analysis, which I discussed in section 5 of this course. Now, since we've actually already performed the problem domain analysis in that particular video, and because the problem domain of a basic calculator application is quite trivial, we're not going to spend a whole lot of time here. What my goal is to basically show you the actual process I would use to build an application in section 7. So we're just going to kind of review what we figured out earlier, and then we are going to build some domain objects and interfaces based on that problem domain analysis. As you can see here, I have the problem statement, or a very similar version of it anyways, which we wrote down in that previous lesson. So what I'll do next is I will make some deductions based on what I have written out in this problem domain, and we will use those deductions to figure out what kind of simple objects and interfaces we will need to build our application. So right off the bat, for number 1, we will need a data structure to represent an expression, a binomial expression, and a result. Now, fortunately, both of these things can be represented with a simple string object, so we don't even actually really need to build a domain model for that. We can use just the Kotlin standard library string, and that will be sufficient for that particular part of the problem domain. Now, for deduction number 2, obviously we will need some kind of back-end object responsible for solving an expression. But actually, we are only going to be looking to solve valid expressions, as I mentioned up here in the problem statement. So, based on prior experience in designing many applications, this is already kind of a hint that we can apply some separation of concerns. So, validating an expression and solving an expression are two different sort of forms of logic. They're similar in nature, but they're two different concerns or operations that we need to take. However, they both work upon the same conceptual domain model, which in this case is just a string or an expression. So in this particular case, since they work on the same sort of data object, we can have a facade, but we're also going to want to have some interfaces in the back end as well to represent these distinct operations. So what we're going to do is we're going to need something which just solves an expression, and then in the back end, the thing that will be kind of hiding from the front end, we're going to need something which validates an expression, and something which I could say solves an expression again, but just to basically use a different word to be less confusing. We're going to say evaluates an expression instead of like solving or calculating. And yeah, that's basically all we're going to need for the back end. So that's just about it for our problem domain analysis. There is one thing which I will include here, which I haven't actually drawn this from our particular problem statement, but this is something I have done in pretty much every application I have written since about 2017. We're going to want some kind of result wrapper object. And the purpose of this result wrapper object is it allows it to make it so that single function calls, say for example to the backend, are capable of representing different states, so success or failure, through one single function call. And it basically works by having this result wrapper capable of representing different states. I've mentioned this before, but this result wrapper construct is based on the either monad in functional computing or functional programming. But this is actually just a terrible name unless you happen to be really familiar with lambda calculus, which I'm going to assume most of you aren't. So not to denigrate functional programmers or lambda calculus, but we're here to learn how to build GUI applications, and it's easier for me to just call it what it is. All right, so we're going to get to work now building our domain objects and interfaces. So we're just going to navigate to the main package here, whatever you called it. I'm just going to click and drag this so you can actually see it. So I'm going to immediately add a new package here, and it's going to be called domain. And in the domain package, we're going to place our result wrapper. So I'm going to right click, go to new Kotlin file or class, and we're going to call this result wrapper. I used to just call it result, but there's actually already a type in the Kotlin standard library called result, which amusingly enough, you're not even really supposed to use. So anyways, that's why I have the long name there. All right, so you should be fairly familiar with building these result wrappers, but I'll just walk you through it in this particular case. So of course we have sealed class, result wrapper, and it's going to have two generic types. So we're going to call one E for error or exception, and we're going to call one V for value, which will represent the success case. And within this result wrapper, we're going to have two subclasses. They're both going to be data classes. So we have data class success, out V. So as a brief aside, if you're wondering what this basically means, it's almost impossible for me to simply explain declaration site variants, but really all you want to pay attention to here is that the reason why I've said out E and out V is that these are values or types which this class is going to be producing, as opposed to values which the class is going to be consuming. They're going to come out of this class when we request either the exception or the value of the result wrapper. Probably that doesn't help too much, but I'm not going to give a big, long technical explanation here because it would involve a whole bunch of really annoying jargon, which I'm not a fan of. Anyways, just understand we're going to be producing these values, and we're just going to carry on finishing our result wrapper class. Anyways, so we're going to type out V and then value of type V, and then we need to extend our parent class result wrapper, and we're going to type nothing and V. So the reason why we're typing nothing here is in the case of a success, we obviously are not going to have any kind of error present. So nothing basically indicates to the compiler that this thing is never going to be accessed. It kind of doesn't exist. It's irrelevant. I'm going to click here and then hit Control D, at least on Windows. And then we're going to type error, out V again, and we're going to type error instead of value there, of course. Then we're going to swap these things. So we're going to have type E, and then in the value wildcard type, we're going to type nothing. And it looks like I forgot to change that to E, and that to E, and that should get rid of our error there. So we could pretty much leave things here if we wanted to, but I like to create kind of a handy little factory function, which basically allows me to wrap function calls and basically consume the result of those function calls, and all of this is going to make it so that we can conveniently create either a success result wrapper or an error result wrapper without having to kind of explicitly call the appropriate constructor. So how we're going to do that is we're going to make a companion object, which is going to be called factory. And this thing's going to have one particular function. We're going to type inline fun. We're going to supply a type here, v build. So what does inline mean? It basically just means copy and paste. So wherever we call this build function, the actual function that we'll be writing here, our build function, will actually be basically copy pasted right into the call site, is basically what that means. I'm not sure if I actually covered that much in the course, but that's what inline means. It basically means copy paste. Anyways, we're just going to type function, and that'll be whatever function call we want to wrap. And that's going to return something with function type here that will return some value of type v. Then this function itself is going to return a result wrapper of type exception and v in this particular case. And then we're going to use some single expression syntax. And so what we're going to do here is we're going to make a try catch block, and this is kind of where the magic happens. So if we are let me just type it out and then I'll talk about it. So if the function we call is successful, returns v, then we can actually just create our success result wrapper here, our success data class, and we're just going to do that by calling function.invoke. So what it's going to do here, so if you're familiar, you should be familiar with function types. The way we invoke a function that we pass into another function is we call this invoke function on it. That's a lot of functions. So what's going to happen here is if this is successful, it will go ahead and build that success data class. However, if an exception is thrown, we're going to be able to catch that here. And I'm just going to take E, and then we'll type exception here. I'm going to select the Kotlin type, which actually just gets mapped to the Java exception class, so it doesn't even matter. But yeah, and then the final thing we'll do is instead, if an exception is thrown, we want to basically catch that error and wrap it in our error data class. Okay, so the next thing we're going to do is we are going to build our interfaces. So the first one we'll put together is the Facade, which I'll talk about in a minute, why I'm calling it a facade instead of a repository. Let's just build it first and then I'll explain that. So I'm going to right click on the domain package again. I'm going to go to new Kotlin file or class, and this one is going to be called iCalculator. And again, I mentioned this before, but the reason why I'm prefixing it with I is just to indicate that it is an interface. And this particular interface is, of course, going to be called interface iCalculator, and it's only going to have one function, which we'll type out now. This function is going to be called evaluate expression, and it is going to be a suspend function, which is part of the coroutines. So I'll talk about how that works a little bit later on, but just make sure you have that suspend keyword in there. Then we're going to type fun evaluate expression. And there's something kind of interesting that's going to happen here. So for the parameters of this interface function, we're going to type exp for expression, which of course is just going to be a simple string. And then we are going to actually leverage Kotlin's function types to pass in a callback function into this function. So we'll see how this kind of works later on, but just understand we're just using a Kotlin function type. We're going to be passing a function in here, and when we compute the result, we're actually going to be calling this function. So what that's look like is I'm just going to call it callback because that's a good name for it. I'm just going to hit enter to get things on a separate line here. And what this function type is going to be is it is going to be our result wrapper. So we're going to type result wrapper, exception, string, and this particular function is going to need to return, in this case, unit, which basically means void, nothing, because we're not actually returning a value from our suspend function. We're going to be returning the value by invoking our callback. Now, the thing about this approach, if you're not really comfortable with it, you could just go ahead and return a plain old result wrapper from our suspend function here. That's another way to do it. Basically, I just wanted to experiment with passing functions into other functions and things like that. I think it is kind of a neat way, and as we'll see, this will actually make it a little bit easier to build and test the class, which will be basically calling our iCalculator interface. Now, before I proceed to the other interfaces, I just wanted to take a moment to talk about why I have called this thing a facade, or why I will call it a facade instead of a repository. So the truth of the matter is, if you build a facade pattern, this is a design pattern, and you build a repository pattern, and you take away the names, but you make a UML diagram, so we're thinking like those programming diagrams with boxes and sticks and names. If you take the names away, you basically pretty much can't tell, well, sometimes you can, but it's really difficult to actually tell the difference between this concept of a facade and this concept of a repository, because fundamentally what we have going on is we have basically a back end, or doesn't have to be back end, but usually it is a back end subsystem which is hidden behind an abstraction, which in this case is an interface, although you could use an abstract class as well. So fundamentally, the facade and the repository are the same pattern, like I said before here. The only difference is that this word in English, repository, and in technical English as well, it implies some kind of data persistence, a data repository. So in this particular case, we're not going to be storing the data any longer than it takes the few milliseconds to compute the answer. So for that reason, I'm going to refer to this thing as a facade. But like I say, just understand it's basically the same pattern from an architectural point of view. Okay, so the next thing we're going to do is we are going to put together our evaluator and our validator interfaces. Now, if I was building a multi-module application, I would have a specific domain module, and I would actually put the interfaces for the backend in the domain module, not in the data module or backend module, as I would typically call it, a data module. The reason for this is if we do what we're going to do now, based in just a single module style, if we were in a multi-module setup, I would have to have my domain module depending on my data module in order to have the implementation of our calculator actually communicate or know the backend repositories. That would be bad. You should not have a domain module depending on a backend module, essentially. If you're not concerned about multi-module projects, don't worry about what I just said here, but for those who are, I just wanted to mention that this is not the way I would do this in a multi-module setup. In any case, I'm going to right-click on the main package, go to Kotlin filer class, we're going to go to new package rather, and we're going to call this package just data is fine. And in here, we're going to put some implementations and interfaces. So the first interface we're going to create is evaluator. And that will, of course, be the class interface, that is responsible for evaluating a valid expression. And the function there is going to be suspend fun evaluate expression exp, which is of course going to be a string, and we're not going to do anything silly with passing a function type in here. We're just going to return a result wrapper of type exception and string. Alright, so go ahead and right click on the data package again, go to new Kotlin filer class, and we're going to type iValidator interface iValidator, and in here we're going to have again one single function, fun validate expression exp string. Now in here we could return a result wrapper, but there's actually a much simpler data structure which we can use to represent success or failure in this particular case. We're just going to return a simple Boolean because, like I say before, it can return true or false, which will be sufficient to represent success or failure. So that's it for this lesson. What we'll be doing is we're actually going to leave the problem domain analysis and the things we built alone for a while. We won't actually implement them right away. Instead, now that I have a rough idea of what the data in the problem domain looks like, now I can start to design the user interface. So that's what we'll be looking at next.